As expected, the temperature is decreasing.
Anyway, the kernels, Haaniyah, the kernels. Did you know that apparently Americans consume 13 billion quarts of popcorn annually? What's a quart?
I don't know.
But that's a lot.
It's crazy because it's all ready to eat prepackaged popcorn, which I get it. It's cheap. You can get it everywhere.
Yeah.
But it's so bad for the environment.
Yeah, that's because it's probably a mass manufactured, which means that it's like an energy intensive process.
For sure.
And also, I think the packaging isn't recyclable, and people just throw it away, right? So that just goes into the landfill.
And the fact that it's gonna increase by 7%, I'm glad because that means we can slide our way in. But that means we really need to go for what we care about, which is low waste, easy to use, and inexpensive. We could play around with solar panels,
but the sun is so hot.
It is.
We can just do that. Hi, Professor Sandra. Do you want to join our video? Oh, I have an idea. Let's consult Professor Sandra. Our popcorn
For mini design.
We're trying to make a popcorn.
I don't see any popcorn here.
Okay, listen, you don't need to rub it in.
So that was our meeting with Professor Hassam Sadiq.
That went well.
Didn't go so well.
Following our previous conversation, we decided that we would like to focus our project efforts on creating a popcorn maker that would use some sort of solar energy. As Haaniyah and Maira mentioned, we could use solar panels, but we thought we could do something a little more interesting. So of course, our only option was to use solar thermal energy. After a load of research, we found that this unique approach would work by focusing all of the sun's rays using a parabolic reflector onto a focal point, where a popcorn would be popped. The idea to use radiation as a heat source was heavily covered in heat and mass transfer, and we thought it'd be interesting to try it out. So, this is where our main objectives are born. That is, environmental sustainability, minimizing the total cost, and maximizing efficiency. To achieve environmental sustainability, we thought our best option is to use a sustainable source of energy, like the sun, and minimizing waste, as Maira and Haaniyah pointed out earlier how wasteful popcorn making could be. We wanted to achieve low cost by lowering the cost per serving and cost of the materials. And finally, we want to maximize the efficiency by minimizing the time to pop the popcorn and maximizing conversion of solar radiation to thermal energy.
After a few drawings, our original design looked like this. As you can see, there is nothing holding up the popcorn holder. We also did not have a base or a holder for the parabola. Realizing that things don't float, we added basic sidewalls. During the initial test, the side kept getting in the way of the sun and causing random shades. Also, these sides were more individual, unconnected pieces, and the design was becoming a braking hazard. We also had issues finding the focal point, and thus decided to change the walls. The benefit of these walls was better support, the option of changing the focal point, a generally slimmer design, and the ability to connect all of the pieces together. We achieved a secure connection by realigning the divots. Instead of the base sitting on the divots, we found it easier to have an inserting mechanism. Moving on to our superstar, the parabola. This was originally made out of solid cardboard, and that was a huge fail because of the lack of strength it had. It was also a little too small to be able to generate enough heat. And so, we made the base of the parabola into a rack. This allowed us to have fewer individual components, making our design less bulky and cheaper. To make the changes we've mentioned, we used some specific manufacturing techniques. For the parabola, we used a laser cutter to cut individual cross-sections. Originally, we cut a bunch of cardboard layers and glued them together. There were many issues with this design, as you can see.
So Maira, why did we decide not to make this out of cardboard?
As you can see, Sandra, Younis, cardboard is very sturdy. As expected, it remains its structural integrity even when it's slammed into with a door.
For the next iteration, we used MDF. By inserting less layers into the racks, we had a more skeletal design. For the rest of the design, we used a combination of manual machining and CNC machining. For the parts that needed a little more precision, like the walls, we used a CNC. For the rest of the parts, we used manual machines. Also, we used a 3D printer to print a collet for our bearing to sit in. A major tool we used throughout our project was SolidWorks. We used it not only to modify and model our design throughout its various stages, but also used the thermal simulation functions to test our design.
Oh, sorry, ma'am. Can you talk us through what you're doing right now?
We're doing the thermal simulation. So this is what's happening. It's taken quite some time, and we don't know if we have it right, quite frankly, but we hope we do. This is based on the assumptions that our reflective surface is pretty reflective, and B, we are starting at room temperature. Something's happening.
Whoa,
Yeah.
it's getting pretty hot.
As expected.
The temperature increases. Day 261 of testing the solar cooker. It is very hot outside. What's this?
We have hit 195.8. It's the highest we've gotten to.
I'm so proud.
The popcorn is...
Burning?
Is it maybe? I don't know. I can't tell.
Our kernels have unfortunately burnt. That's all I have to say. If you need any more information about popcorn, you can Google it.